Okay, welcome to Introduction to C Programming. The program we're going to write today is using switch statements. Here is the program. We're going to write a program to prompt the user with a menu. We're going to ask the user to enter two numeric values and then provide a menu to ask what operation the user would like to perform. Plus, minus, x for multiply, slash for divide, and the percent sign for the modulus operator. And then we're going to perform the corresponding operation within a switch statement. Okay, so go ahead, start off by opening Visual Studio. And once you open Visual Studio, we're going to create a new project. Make sure you select the Win32 console application. I'm going to name this project switch statements. Say OK. This next screen, click Application Settings. Say Windows Application and Empty Project, and then click Finish. Oh, I'm sorry, make sure this is a console application, not a Windows application. Make sure you click the empty project and then say Finish. Okay, under Source File, right click, say Add New Item. And we need to create a new C++ file, the .cpp file, and we'll name this switch.cpp. Say add. This should give us that blank file here in the middle of our screen. Okay, so if we want to do any kind of input or output in our C program, we have to include a specific header file. That is the standard io.h header file. The entry point to all of your C programs are going to be the main function. We write the main function that returns no parameters, which would be void, and takes no parameters, parenthesis, parenthesis, and then we open the curly brace, go down a couple lines and close the curly brace. That's the body of the main function. If you are using a Mac OS or Linux, you might not be able to get away with making the main function return void. So in that case, you would do return int, and then down at the very bottom of your code, you would make a return 1, something like that. That's the only difference. You'll understand what the return type of int means and why we return 1 when we start talking about functions, because we'll talk about return types. You'll understand that. That's the only difference, though. If you happen to be running this in a Mac or a Linux environment, or for some reason if the void doesn't work, not all C or C compilers will want you to have a void return type for the main function. Okay, we want to prompt the user to enter two different values to start. So before we can do that, we need to create the two values. We'll call them value 1 and value 2. We'll make them both integers. If you want to make them floats, you can do that as well. Doubles, that would work also. It's your choice of what type of variable you make those. These are just going to be the ones that are read in from the user. Actually, why don't we go ahead and change these? Let's make these double values just so that we get some experience using a different type of a variable rather than always using int variables. So we'll make them both doubles. That's value 1 and value 2. Now we need to prompt the user to say enter number 1. And then we're going to read it in. We use the scanf function for doing that. If we're going to read in a double instead of an integer, it is going to be a %f. And we're going to put this into value 1. And then we're going to prompt the user and say enter number 2. And then read in the next one into value 2. Okay, this has prompted the user, asked them to enter two different numbers, and then we've read in those numbers back to us. Hopefully you've been taking my advice and you've been writing just a couple lines of code and then running it to make sure that it outputs correctly or that it's working correctly. You don't have any compilation errors. So what I'm going to do here, %f followed by a new line, I'm just going to put a little output statement here, and let's make sure that value 1 and value 2 are being read correctly from the user and then get printed back out correctly here. So after you do that, I'm going to go ahead and build my project. Let's look down at our output screen here, make sure that it comes back and says build successful. There it is, build succeeded. Go up to debug, say start without debugging, and it should prompt me to say enter number 1. Let's enter it, 15. Enter number 2, 23.45. And then I say enter, and something didn't seem to work right there. Okay, the problem that I have here is that I actually have tried to read these in just as floats, and they're not in fact floats. They are a double variable instead of just a float, and I'm trying to print them out as floats. That's not going to work. Instead, I need to read them in as doubles, which would be a long float, LF. So if we do that with the LF, and now let's build it. It still compiles. We run it, and now let's enter our numbers. Now you see that they are going to print out correctly. If we want to deal with the precision of those variables, maybe we only want 2 decimal places instead of 6 decimal places, we can do that just by putting the .2 in the middle of the percent sign and the LF. So if I did something like that on my printouts, remember every time that we make a change you have to recompile your program in Visual Studio. It's you do that through building it, and now you see that my numbers are output just with 2 values after the decimal place instead of 6. And that's just by doing the %.2, and then you put the type of the variable after that. In this case it's a double, so we're going to do LF, which actually stands for long float. Okay, so I'm going to comment that line out because we don't need that line. Now the user has entered 2 numbers for us. The next thing that we need to do is prompt the user with a menu to say, hey, what operation do you want to use? Addition, subtraction, multiplication, division, or modulus. So we're just going to create a menu here. And so we'll start off by just doing something like this and say addition, and we'll make a new line. Subtraction, followed by a new line. Multiplication, followed by a new line. Division, and modulus. There we go, and then we'll say which operation would you like to perform? Okay. We're going to have to read what operation that the user wants to perform into a variable, so I'll create a variable called operation. And then do a scanf on a character, which is %c, into the variable operation. Alright, little test. Print it out. Make sure that our operation is going to be correct. Build it, run it. We're not printing our numbers out anymore, so whatever we type there is not going to be printed. We'll just type some numbers. And then you see that it skips right over this altogether. That's because we are reading it with a %c. Okay, so let me show you what's going on here and why that is the case. Let me make this a full screen so that we can see a little bit better of what I'm writing here on the whiteboard. When we are reading values from the user, it all goes into something which is called a buffer. Now the way that the buffer works is it takes all of the input from the user up to and including the new line character. So when we typed in the number 12, what do we type in? I think we typed 12. What it does is it takes those numbers and puts them into individual spots inside of the buffer, followed by the \n. Now, when we have a scanf, or in this case we did for a long float, reading it into some variable. I don't remember what our variable was called now. Let's take a look here. So we're reading it into the variable value 1. What ends up happening is in main memory we have a variable stored on the heap called value1, and it's pointing at some location in main memory where it stores the value of that variable. So in this case, value1 gets stored into a location of main memory, so we have 12 stored there. Now, as soon as we say read a long float, a double, into this variable value1, the operating system is going to pop that number off of the buffer, out of the buffer. Now, when we typed in our next one, we said 23.45, followed by a new line character. And then we had in our code scanf a long float on value2. So we get value2 on the heap, pointing at some location in memory, and we are going to now get the next double value out of the buffer. Well, the compiler is smart enough to know that this \n is not a numeric type. It's not a number. It's not a double. So what it does is it ignores it. And then it takes the next value, all of this, as the double value. So it takes 23.45 and puts it into main memory. And then it pops that out of the buffer. Okay. Now you notice that there's still the \n remaining in the buffer. So now we printed out the menu to the user, and then we had a scanf for reading a character, and we named this operation. So the operating system is going to put a variable called operation over here into the heap, pointing at some location in memory, and it's going to look in the buffer and say, is there a character already in the buffer? In fact, there is already a character in the buffer. A \n is a character. So it takes the \n, puts it into main memory, and then pops it off of the buffer. So what we're getting here is we're actually getting the \n into main memory for our operation, and instead we want it to wait and prompt the user and wait for them to type something. Now, the way that it waits for the user to type something is if there's nothing in the buffer right now, or nothing that can be read into that variable type, then the program is just going to wait. It's going to sit there and it's going to wait for the user to type something, because then that's going to put something into the buffer so that it can grab it and put it into main memory for that variable. So what we're going to need to do here now is probably, let's go back to our code. One way that we can take care of this is when we are reading this variable right here, we know that there's going to be a \n already in the buffer. So maybe here, if we just do a scanf, and we can read this into whatever variable we want, this one's going to be thrown away because this is just going to be \n, the new line character. If we do that and then we read here operation into another character, this is going to take care of our problem for us. Okay, so let's go ahead and run this, build it up now and run it. Let's make sure this is actually going to work for us. And so we enter our two numbers, and then you see it still says what operation would you like to perform. Let's choose one of them, like the plus sign. And you see then that it prints out our operation for us. So that's the issue with the buffer, and that only happens when we are trying to read characters. When reading characters, the \n is going to get read in as a character, but it does not get read in as the last character of a numeric type. Okay, so now you see that we have our operation read in. We have our two numbers read in correctly. So the next step is we need to have a switch statement where we perform whichever operation we want. So we're going to switch. The variable on which we're going to switch is that variable called operation. It's a character, so that works for a switch statement. The different cases we have, the first one is going to be the case of a plus sign. You notice that Visual Studio likes to justify this with the switch statement. I personally don't like that. I always go back and indent it a little bit more. Whenever I write out my statements, I usually also put my break statements in right away so that I don't forget to do it. So I go through all of my cases putting my break statements, and then I go back through and I will enter whatever the body of each one of those statements will be. Okay. and we like to do a default statement at the very end so that we can say, uh-oh, you didn't enter the plus minus x divide or percent sign. So we'll go ahead and output that here. You didn't enter a valid operation. Okay, now for each one of these, the break statement is going to be the last line inside of the body of the case. And then inside, what do we want to do? Well, if they entered plus, we want to add the two numbers together and output them. So maybe we'll just say printf one long float plus another long float equals another long float. And we say this is value 1, value 2, and value 1 plus value 2. Okay, we can do the same thing for our subtract. Oops, make it minus instead of plus though. You can do it for the multiplication. Now I'm putting extra parentheses around these mathematical expressions over here. You don't have to do it because they have higher precedence than the commas that we have there. I do it just to make it a little bit clearer, a little easier to understand. Okay, the division. And the modulus. Now the only thing that's going to be special about the modulus here, actually let's just go ahead and try this and see what comes out on the other side. We're going to see that there's probably going to be an issue with the modulus operator, but let's give it a shot and see what comes out for us. Okay, when we do that and we build it, you see that we have the build failed, and here it shows on line 39 for the percent sign, illegal left operand has typed double. Okay, this is going to be an issue since we read in long floats, since we read in doubles. We're not going to be able to perform this percent sign operator here because we have to have int values on each side. So we're not going to be able to do the modulus operator unless somehow we can convert these values to integers. Okay, now the way that we can do this, we have double values right now. We can just chop off the decimal places altogether and make these integers. The way we do it is through a method called typecasting. So in front of each one of those variables, put a parenthesis, type int, and then close the parenthesis and do it immediately before value 1 and value 2. What this is going to do is this is telling the compiler, I understand that these are not integers, however, I want you to make them integers. And when we take a double and we make it an integer, it's just going to chop the decimal places off the end of it. The only other thing that we need to do is when we take the modulus, we're not going to get a long float. Instead, we're going to get an integer. So change that %LF on the right side of the equal sign to be a %D. Okay, after we do that, save it, build it, run it, see what happens. Build succeeded. Okay, here we run our program. Let's enter a couple numbers here, 35 and 8. And let's do the add. 35 plus 8 is 43. Well, that's pretty good. We can format that output. I showed you how to do that. Make it a %.2LF instead of just the %LF, and that'll work. I noticed something here. The modulus is not showing up. That's because the percent sign is a special character. I missed that when we were doing this, so we actually need to put 2 percent signs in there instead of just 1. So up here at the top, when we do the printf for the percent sign for modulus, just make it 2 percent signs so 1 actually gets printed out there. All right, let's run this again. I'm going to build it up since I just made that little change. Let's run it again, make sure that it comes out. Let's do 35 and 8. Now you see the percent sign actually does show right there in the output. And let's subtract them. So there, that works. That looks pretty good. Let's run it again. And let's do 35 and 8. We're going to multiply them. 35 times 8, yeah, that looks pretty good to me. Okay, let's run it again. 35, 8, let's divide them. Get 4.375. Oh, alright, pretty good. We're actually using those decimal places now. And the last one, let's find out what happens when I do the modulus operator on 35 and 8. And, uh-oh. ran into a little bit of a problem here. Again, the problem has to do with this percent sign. Since I put the percent inside of there, we need to do 2 percent signs if we actually want it to print out 1 percent sign, since that's a special character. So make that 2 percent signs, compile it up, run it again, and let's try it. And there you have it. So when we do 35 mod 8, well, 8 times 4 is 32. We have a remainder of 3. You see that we get a 3 on the output. All right, so that takes care of our program for today. Let's see how much of this I can get on the screen. Can't quite get it all on the screen for you, but there's most of it. The code's going to be posted on the website, and let me know if you have any questions. All right, good luck.